Welcome back to part 2. In this, we will cover shear force and bending moment diagram for cantilever beam. So first, we will take a cantilever beam of length L carrying a concentrated load W at the free end. So in simple, this is a cantilever beam A and B, length L, and having a concentrated load W at the free end. Okay, so we will move from free to fixed end in this from point B to A. So first, I'm just showing you how to select the sign conversion for this SFT. So in this, as you can see, the section is we have taken XX as a section. Okay, so this is the section towards the right, and the load direction is downward. So as you can see here, and this rotation or combination of this is clockwise. So we'll take this as a positive. So simply, this shear force will be a positive W, and at x is equal to 0 means point B, the shear force will be W like this, and at x is equal to L, the shear force will be W like this. So in this, as you can see, from A to B, there is a constant shear force because there is no other concentrated load between A to B. So that's why this W is constant throughout the beam. Second is the bending moment diagram. In this, as you can see, the load is downward on the cantilever beam, and the effect may be like this. So bending will be like this. So we'll call this hogging, or simply this is a negative, or we can say simply a side mode for just remembering. And this from section B to A, the formula is simply minus as negative sign, force into perpendicular distance. So force is W, and x is the distance. So we are just you can just see here that this is W and this is x. Okay, so simply W into x. So this is the moment. Now put the value of x. So first we will put the value of x is equal to 0, then the mx will be 0. So simply bending moment at point B is equal to 0, and second at x is equal to L, or we can say simply at point A. So MA is equal to minus WL. So maximum bending moment is WL. Okay, so in this, as you can see, the maximum bending moment is WL and negative sign. So this is complete. The second one is a cantilever beam of length L subjected to several concentrated loads. So as you can see, this is a cantilever beam, length L, A, and point D. Here are some concentrated load like W1 at point D, and W2 at point C, and W3 at point B. Okay, so this is a reference for SFT. This is reference for BMD. So first, again in this, we will go from this free end to fixed end. So now first, this is for load W. So at x is equal to 0, the effect of W1. So simply at point D, the shear force will be W1. Okay, now next at point C, x is equal to A. Okay, so now this shear force at point C is equal to W1 plus W2, as simply you can see here. Okay, so W1 plus W2. Okay, next at point B, so shear force will be like W1 plus W2 plus W3. So simply W1 plus W2 plus W3. Simply as you can see again in here. So W1 plus W2 plus W3. And final, from B to A, this will be constant. And at x is equal to L, simply W1 plus W2 plus W3. So maximum shear force will be equal to W1 plus W2 plus W3 at fixed end A. Here, as you can see, between D to C, this is a constant because there is no load. So that's why this is constant. And from C to B, intermediate, there is no load. So this will be again a constant. And from A to B, this is also constant. So this is shear force. Now we're talking about bending moment. So bending moment, in this again, we will go from free end to fixed end. So simply D to C. So first, the equations for bending moment is simply force into perpendicular distance. Okay, and this minus sign because of the hogging conditions we already discussed in point 1. Okay, in this simply we are taking this first w1, okay, into x. So this is x. So w1 into x, so force into perpendicular distance. So mx is equal to minus w1 into x, and simply this x is equal to 0, then md is equal to 0. So at point D, the bending moment is 0, and at point A, the bending moment is minus w1a, because we have put the value of x is equal to a. So final the bending moment at point C is equal to w1a. So simply you can see here, okay, so w1a. Now next, from section C to B, we will again make a question for this. So in this first, you can see this mx is equal to minus w1x. This is same, but I have put this minus w2x minus a. Why? Because we are taking reference from this D. Okay, so now the section is like this. Now section is like this. This is xx. For w1, this is same x. This is x for w1. Okay, no problem. But for w2, we have to select this length, and this length is equal to what? This total is x, and this is a. This is a. So simply this one will equal to x minus a. Okay, this is simply x minus a. So we have put here, this is x minus a. Now next, if we put the value of x is equal to a, then the mc is equal to minus w1a, and if I'm putting the value of x is equal to b, then value of this is equal to this. So just put the value in the bending moment diagram, then you can see, okay, this one. So at point B, the bending moment will be like this, and the effect of load W and W2 both will occur on this point B. Next, from B to A, the equation, first we will make an equation. So again, this equation is like, again, this is W1x, okay, W2x minus A, okay, but minus W3x minus B. Why B? Because now the section is here, because we are talking, we are talking about this, na? The section B to A. Okay, so in this, now, this is the x total. So this is total x, and this is B. So just the value of this is equal to x minus b. Okay, so I have put here x minus b, as you can see here. Now put the value of x equal to b, then the value you will get the same value like this. Okay, and the value of x is equal to l, then this is the final, and we can say maximum bending moment in this condition. So this is the maximum bending moment for this.